Hello, this is Pat Kelly. Okay, in this problem, they give us a linear differential equation and a couple of initial conditions, and they want us to find the particular solution to this differential equation. So let's get to it. I really like these types of differential equations when they're linear like this. What you do to start is write your characteristic equation, which is just when we put m's in here and make it look like a quadratic instead of a differential. All right, and I like that because then you end up solving this with some good old algebra skills. I do think mind factors, but when you're doing yours on your own, do whatever it takes. Factor, great. Quadratic formula if you need to, do whatever it takes. And I think mine's going to have 6 and a 5, and I need that to be negative and this positive. All right, FOIL to check, but I think that looks good. So we get down to m equals 6, or m equals a minus 5. That's great for algebra class. Now to step it up to like a differential equations type problem, what do you do with those values of m? I'll switch colors here, just because each of these then gives you a solution here, like I'll call the first one y sub 1. And the m value gets placed in the exponent of e as a coefficient of x. And there's y sub 1 and y sub 2. Since I have two values of m, I just do the same thing. E raised to the minus 5x power. Okay? Then you take those two different y sub 1, y sub 2 and put them together with a linear combination. I'll slide over here for that. And so y without a subscript equals c1 times that e raised to the 6x power plus c sub 2 times that other e, the one that's raised to the minus 5x power. Okay. All right, so that would be our general solution, but they did give us a couple of initial conditions, so we're going to find the particular solution, which means we'll find specific values for C1 and C2. All right, in order to do that, I'm going to use these initial conditions, and I can see that one of the initial conditions involves y prime, so let's take this y that we have and prime it and differentiate it so that we'll have something to plug in the initial condition. So if I differentiate this, I'm looking at 6 c sub 1 e raised to the same 6x power minus, because that minus 5 will come out in front and multiply, times the c sub 2 e raised to that minus 5x power. Okay. Now to use those initial conditions, I'll even keep it color-coded if I can. This y of 0 equals 1, I'll plug into the y equals equation. And it's always so nice when they give us an x value of 0, isn't it? Because you're putting a 0 in here, so e to the 0 power, that's 1. That's going to happen here as well. So this first equation just becomes C1 plus C2 equals, and on the other side of the equal sign, that would be my y value, which from your initial condition is the other side of the equal sign. That's the 1. So I'm going to say that C1 plus C2 equals 1. Okay. Now to use your second initial condition, y prime of 0 equals negative 4, we'll put those specific values into your y prime equation, the orange equation. So again, so nice when they give us a 0 for x. This is going to be e to the 0 again, so it's 1. That's going to be e to the 0 again, which is 1. So that equation is going to become 6c1 minus 5c2 equals, and the other side of that equation, the y prime, would be the negative 4 from our initial condition. Minus 4. And what you create for yourself is a system of linear equations. We've done a million of these, I think. Solving this, I think what I would do is probably multiply that yellow one, the top one, by 6 to get our coefficients to line up. 6c1 plus 6c2 equals 6. And then adding these two, actually I'm going to subtract them, aren't I? I'll subtract the bottom minus the top here, so 6c1, of course that goes away, but 6 subtract a -5, that's just why I did the order that I did. I'd have 11c2, and subtracting 6 take away -4, so adding 4 looks like 10. I get a c2 of 10/11. Nothing wrong with a fraction, right? Okay, now I take that value of c2 and I'd be plugging that in here. So my c1 I still don't know, but c2 is 10/11, and that equals 1. So c1 equals, see if I subtract that over, this is like 11/11, take away 10/11, looks like 1/11, and that's awesome. We've got our C1, we've got our C2. I'll slide over here just where I have a little bit of room. Our final answer, they wanted the particular solution. I'm just putting in my specific values of C1 and C2 into the yellow here, into my y equals. C1 was a 1/11. Keep going with what else is here in yellow. E raised to the 6x, and then plus my C2 that I now know is 10/11 times that e raised to the -5x. And that's it. That's our particular solution. Okay? Try some more on your own. I know you'll do well.